the things that went wrong here in people's understanding of probability summation. This option number one, it looks so innocent, but this is sort of the treacherous summation over a condition variable that catches people all the time. The example that I always like to encourage people to remember for this is, probability that it rains in Seattle, given that, day of the week equals whatever. So when you remember that example, hopefully you'll remember that summing over a condition, summing a conditional probability over a condition variable is going to give you something that isn't even guaranteed to be a probability, right? Because that could easily be greater than 1, right? I mean, it's 70% probability that it rains, given that it's Monday, given that it's Tuesday, given that it's Wednesday. We're going to get 7 times 0.7, and it's not even, can't even be a probability. It's greater than 1, right? So the best way of thinking about summing a conditional probability over all possible values of the condition variable is it's basically undefined. I mean, it's not even a probability. Sometimes people think that this sums to 1. Sometimes people think that it sums to the probability of A. Neither of those are true. It's just undefined. Okay, so watch out for that one. That's a misconception that will really steer you wrong. If you're not making the connection from the joint probability summation to the unconditional probability, then you're basically forgetting about our main function for summation, which is to eliminate a variable from a joint probability and reduce it to an unconditional probability. Basically, eliminate one variable from our joint probability. This is a really, really, really key usage. So it's very important that you understand it and know when it applies and how to use it. Let's see. So, any questions about this?
Something you could do with
So you're talking about this crazy ratio?
Yeah.
Yeah, it's. I mean, I guess you could sort of think of it as being like an odds ratio of some state of A versus each one of the states of B. But what is that? It is not really clear what that means. You can think of this as we factor P of A outside, and then we're summing the reciprocal of a bunch of probabilities. What does that mean? I mean, maybe there's some situation where that's meaningful to you, but in this context, it really didn't have any relationship to any of the other things. So you had a question?
Yeah, I just wanted to bring up the point that for number 4, the probability of B could be like 0.1 for something, and then you already have a probability, like some probability of 10, at least, or possibly more. So
yeah. I mean, you can make crazy values with this. I mean, it's kind of a little bit related to like an entropy. I guess you could think of like how spread the probability is of all the values of B or something like that. But anyway. Right. We can just factor this outside of the summation because this doesn't depend on B, right? This term does not depend on B.
it's not B, but it's I.
Here we were just saying we're summing over all values of B.
But you're able to pull out.
Sure. Did I answer the question? Why don't you just very briefly click on the assess link.